Welcome friends, this is another video where I am picking up another small machine learning project. What we'll be doing is we'll be taking up some sample passport profile images of subjects and we'll be converting or cartoonifying the images, basically converting that image into an image which will be similar to a cartoon version of that image. So this is a very basic project in machine learning that uses OpenCV. It's an OpenCV is a package that helps using machine learning for basically computer vision related problems, and it's a very common and very popular packages. So let's get into it. So first we will be importing the CV2 module, which is the actual OpenCV module. Again, if you want to see or if you want to get an understanding of all the packages and the environment that I have set up here, so you can refer to the GitHub page of this project, and there is a requirements file where you will be able to get all the packages that I am using and I have got installed, so that you can also map the same packages in case the environment is not working for you. So okay, so getting into it, so we'll be using OpenCV, and then we'll also be using the famous pyplot plot function from matplotlib to plot the images. So the first step is we'll import the packages. Then what I have done is I have already picked up these sample images which are available at this location, and I'll be referring to these images from this sample image ID. So let's start with the first image only. So I'll be referring to the sample image 1. This is the image, so this is the subject. These were available in public domain. These are images that were available in public domain, so I picked it up from a simple Google search. Now the first step, what we'll do is we will read this image using OpenCV. So for that we will be passing the image path and then using the image read function, which will basically load the image into the OpenCV environment so that we can use that image and apply additional functions. The second thing is we will be using the CVD color function, which is basically to convert the color format or basically it is used to transform the RGB color space that the default image has into a space that is more relevant or more aligned to OpenCV. In OpenCV the way the images are being processed is actually the opposite of RGB, which is BGR. So your first pixel is not actually red, instead it's blue. So blue, green and red, that's the actual order when it comes to processing the images. So we have to use this function to convert the images according to what OpenCV needs, and after each of the function that I'll be applying, I'll be plotting the image to show what image we have got, or at what stage how the image looks like. So this is the first step. We'll simply read the image and convert it to the corresponding OpenCV format, and now you can see that we can see this image. It looks as expected. Second step is we will convert the image into a grayscale image. So this is where we use this gray. Basically we'll use the same function, but this time what we are going to do is instead of using the default or basically converting BGR to RGB, will be converting BGR to gray. This attribute is actually the code attribute. So source is the source image, code is the kind of code that we want to use. So this is the CV to BGR to grayscale code that we are going to use here, and if I plot the image, we will get the grayscale image. Third step is we will smoothen the image out. So the sharpness around the areas where there is a stark contrast, the smoothen function will smooth the image. That will help us in identifying the edges, which will be important later on, because we are looking to cartoonify the image. So the edges of the what you call the edges of the core areas is very critical. For example, if you do not smoothen, then all this sharpness around the eyelashes, also all this sharpness in the hair, that can interfere in the way the image will get processed. So we'll be using a median blur function. This will basically smoothen the image, and for this we have a attribute called k size. K size value is what we pass, which will decide how much or how far the smoothness of the image should go up. So we'll be using a k size of 5, and yeah, we'll be using a k size of 5, and let's run this, and we'll be passing the grayscale image as input here. So we'll run the smoothen image, and then we'll see how the image has smoothened. Now if you will compare these two images, like I was saying, the very specific sharpness that we have around some places of the image, they have now got smoothened up. You can see the sharpness around this collar, and also you can see the sharpness around the eyes, that has all smoothened up. Also the sharpness around the hair, that has also gone down. Then the next step is we want to identify the edges or highlight explicitly the area where we have very stark edges. For example, this hairline is one of the areas, also this cheek line, as well as these collars and these shirts. So we'll be using the adaptive threshold function here, and we'll be passing the smoothened grayscale image, and the method that we are going to use is called adaptive thresh mean, and then the threshold type will be thresh binary. So if you want to read about all these methods and how the function works, I would recommend that you go through the documentation for this function. I'm not going to go into deep and basically explain these different functions in this particular video, because the idea is we should simply have a very basic project that is using OpenCV to generate a kind of cartoonized image. So that's all. I'll stick to the agenda for now. So we'll be using this approach now. You'll see it is basically just giving us the highlights like we expected. So this is how the image after the highlights being processed, this is how the image would look like. Okay, so next step is, once we get this highlighted image, what we will do is this is part one. So what we also need is basically apply a bilateral filter on the original image, so that we remove the noise, and we are going to get a colored image with noise removed, or basically it will be a similar version to this one, only difference is it will be a colored smoothened image. So for that we'll use this bilateral filter. We'll pass the original image, and we'll pass the sigma attributes, sigma color and sigma space, and then we'll see how the image looks like. So you can see it is still the colored image, but it's much more smoothened when we compare it with the original image. So this is the colored image. Now we are going to use this edges as well as this smoothened color image to obtain our cartoonized image, so or cartoonized output. So for that we'll use the bitwise AND function. Basically we'll use the edged image as a mask on the colored image using the bitwise AND operation. So bitwise AND function, again what it does is it's a conjunction. Okay, so computes bitwise conjunction of two arrays. So whatever are the two source images, that is first image will be our color image, and the second image also. Okay, in this case both the images are the colored image only. The only thing is the mask that we are using is the edges that we have calculated. So using this on the bitwise, and if we plot, we will be getting an image which will actually give us the cartoonized version of the image that we are looking for. So yeah, this is fairly simple. Just maybe 4 to 5 steps that we can use, and we can obtain this cartoonized image for any subject. So yeah, this is fairly a simple project, and somebody who is actually just starting up, I think this is a good project to showcase the capability of OpenCV. One more thing, we can test it with multiple images, like I said. So in this particular notebook, what we can simply do is we'll simply replace it with 2, and if we run each cell again, it will start using the second image and then process the image, and again it will give us the expected output here. So of course, depending on the image, your results might change. Not every image might give you a kind of appealing cartoonized output, but yeah, I have tried to collect some of the images that were available in public domain on Google, and I have used it to test. So yeah, you can keep on playing around with the different image samples that I have provided here, or you can use your own image samples and see how the output is working for you. So yeah, like I said, this is a very simple project, and the idea is to basically impart a basic knowledge of CV2 and OpenCV to the person who is trying to learn this. So I hope you would have liked it. I'll try to upload similar kind of videos for some other simple projects on machine learning, deep learning, and artificial intelligence. Yeah, thank you. Thanks a lot.